The real neural network running inside your head right now is the most sophisticated machine on the planet. But the world's biggest tech companies are spending billions of dollars trying to replicate it inside a computer. Here is the catch. If you don't understand how this artificial dark brain operates today, you will become completely obsolete in the next 5 years. Today on Neural Tools, we are bypassing the boring textbook definitions and decoding the absolute truth about neural networks in under 5 minutes. To understand how this digital brain works, you have to look at its hidden architecture, which is built on 3 distinct node layers. You have the input layer taking in raw data, and the output layer spitting out the final answer. But the real magic happens in the middle, inside the hidden layer. This is where the artificial neural network, or ANN, acts like human brain cells, recognizing deep patterns and solving chaotic problems that standard computer code cannot even touch. Here's the second secret most people miss. Every single node inside this network is actually its own miniature future predicting machine, running a mathematical model called linear regression. When data flows into a node, the computer assigns it a specific weight and a bias. In plain English, the computer is deciding exactly how much importance to give each piece of information so it can accurately predict a future outcome. Let's look at how this plays out in real life with a single node trying to make a high-stakes decision. Should you go surfing today? The final decision is our prediction, known mathematically as y hat. Let's feed the computer 3 inputs. Input 1. Are the waves pumping? That's a 1 for yes. Input 2. Is the lineup empty? Unfortunately, no. So that's a 0. Input 3. Is it completely shark-free? Thankfully, yes. So that gets a 1. Now, the computer assigns a weight from 0 to 5 based on what matters most. Waves are crucial, so we give that a weight of 5. Crowds don't bother us much, so that's a weight of 2. Sharks are terrifying, so that gets a weight of 4. When you crunch these numbers through the algorithm and subtract the threshold, the minimum barrier to make a choice, the final score is a 6. Since 6 is greater than 0, the node outputs a 1. Pack your board. We're going surfing. This forward-only momentum is what scientists call a feed-forward network. But how does a computer know if its surfing prediction was actually right? That brings us to secret number 4, training the beast. We use supervised learning, flooding the algorithm with massive labeled datasets. During this training phase, the computer has an ultimate villain called the cost function, which is basically a scorecard of all its errors. The computer's entire life purpose is to minimize this cost function down to 0. It does this using a brilliant algorithm called gradient descent. Think of it like trying to walk down a pitch-black mountain. You feel the slope with your feet to find the fastest way down. The computer constantly recalculates and tweaks its own weights and biases until its mistakes completely vanish. Finally, you need to know that the tech world has evolved far beyond the basic feed-forward model. There are specialized strains of these digital brains built for specific jobs. First, you have convolutional neural networks, or CNNs, which possess a unique architecture perfectly optimized for advanced image and facial recognition. Then, you have recurrent neural networks, or RNNs. These networks are dangerous because they have a built-in memory loop. By remembering their own past inputs, RNNs can analyze time series data to predict complex future events, from stock market crashes to corporate sales forecasting. 5 breakthroughs, 5 minutes. If you want to permanently rewire your own human intelligence and stay ahead of the AI curve, smash that like button and hit subscribe right now. Because the next time the algorithm serves you a mind-blowing video, you better believe it's going to be ours. This is Neural Tools, and I'll see you in the next one. And